Good morning, everyone. My name is Jerry Stevens. I'm with ZOS ComServer Architecture and Design Group, and I'm here to do the ZOS Communication 2.3 technical update. And what this presentation will be is our 2.3 content, an overview of each of the items. The larger items have been moved out into individual presentations. So one of our main deliverables for 2.3 was ZERT, which I'll just touch on today, but we'll spend more time on it in another session later today at 4:30, I believe the ZERT session is. So with that, so here's a quick look at the agenda, and it's a long list of topics, and it is challenging to get the topics in 1 hour, and I apologize if I'm going too fast. It's a small group, so we can stop and we can talk about it. But basically what I'm going to do is, as I mentioned, I can't cover these all in detail. ZERT itself does take just about an hour. So I'll just touch on ZERT. We'll talk about ZOS mail updates. That's a fairly important change. It's an evolving change that's been going on for 2 or 3 years, but it's something you'll need to know about if you're managing ZOS systems. The rest of them are relatively containable. Wildcard support for port and port range have been updated. ATTLS currency is something we deliver every release. It's kind of a release tax to keep up with SSL and other security specifications that continues to change. Then I have a list of miscellaneous changes that were shipped in 2.3. Each of those are relatively large in itself, but again, I'll at least introduce them while we're here. Config Assistant, we have a long roadmap for Config Assistant, and I'll talk about some of the items that we've added in the last release to continue that roadmap to complete Configuration Assistant. We also have some other smaller items, like we've changed to VTM Internal Trace, made some changes there to allow the user to have more control of that item. So that's just a quick view of what we'll be talking about. This is just a normal disclaimer that anything in here that's talking about future deliverables, I only have 1 or 2. For the most part, everything now has either been announced or it has in fact been GA'd in 2.3. So the first item is one of the main items of our release of 2.3. It's consistent with the strategy of pervasive encryption. And it's this notion of, we've named it ZOS Encryption Readiness Technology, or ZERT for short. And ZERT, I think we're going to find, is a very popular item with our users. And what you'll see here is a quick background about what it's trying to solve, and then how we solve it will be in another session. So what we have today is we have complexity on the platform. As in any platform, we have many options for securing connections. And so the first obvious one is connection level security, which is either TLS or SSL, and that can be direct usage from an application doing that itself. So application is explicitly coding to the APIs. It's using the security infrastructure itself. Configuration auditing is unique to each application. How they audit, keep track, what they do is based on their usage. It's a per session protection, which means a session is a little bit different than a connection. So on a TCP/IP connection, they can begin a security session sometime into the connection. So they can also turn it on and off dynamically. And of course, SSL and TLS is TCP only. So that's one form that's on the platform. And then we also provide, as you know, application transparent TLS access. So this is access that's provided for applications, and what we do there is we provide TLS SSL applied to the TCP layer as defined by policy that the administrators configured for this workload. So auditing is all through SMF 119 records, so it's very controlled, predictable in terms of what you're using for this application. And it's typically transparent. Most applications don't know about this. It is application transparent. There are some parameters and APIs that we've extended to applications to give them somewhat more flexibility. And the TCP/IP becomes a user, the stack itself becomes a user of SSL. So we wrapper the functions and call SSL on behalf of the application. That's the second form of security we can provide on a platform. Of course, this is the same as SSL direct usage, in the sense that it's TCP only. The third version of it is you can also use IPsec and use IKE creating VPNs on System Z. Again, now this is a different solution. As you see with 3, it's basically a tunnel, a virtual private network, if you will. And it's platform to platform. It's no longer just on a connection basis. It's IPsec tunnels. It's implemented at the IP layer, not at the transport or TCP layer. But the auditing is via SMF, again, 119, very predictable and controlled on a pipe basis. Completely transparent to applications, because again, this is platform to platform. Wide variety, any to all of traffic is protected. So now it's not just TCP. It can be anything that flows over that tunnel. negotiates IPsec tunnels dynamically, and then we connect using the protocol itself from some platform to another platform. And then finally, we have a secure shell available using ZOS Open SSH. That's another form that's not as common, but it's mainly used for secure FTP on ZOS, but it also offers yet a secure terminal access and TCP port forwarding. It's configured in SSH in configuration file and on command line figuring. Auditing there is also predictable. It's SMF records 119. Again, it's TCP only. So the background here is painted. You see this at one step at a time, that in a ZOS platform, you'll see that there are 4 popular versions of securing your networking communications. And so with this notion and theme of pervasive encryption on the platform for Z14, what we're trying to do in the release with that platform is give you the ability to find what is secure, what level of security, how do I track it, and you can see the complexity of getting to that answer. And so what we've been faced with, the customers are asking us, okay, given this complexity, how can I tell which traffic is actually encrypted? And if so, what protocol are they using? What protocol version? What's the cryptography algorithm? What's the key strength, key lengths? All the questions you'd like to know. And again, if the application is using it directly like in option 1, they may or may not, their auditing may be completely different. So you can see that the task for the users is extremely complex, and that's really what the customer needs to do when it faces its auditors and tells them what's being communicated securely, what's not. And there's many factors driving this, and it's regulatory compliance, based on corporate industry, government, many things that are changing. They're changing overnight. Vulnerabilities that we see occurring in protocols and algorithms. We see it occurring in the industry every day. That occurs over and over. And so there's just multiple problems with trying to secure communications in a ZOS environment because of the complexity and the variety of options that you have today. And so this is where we've introduced this solution called ZOS Encryption Readiness Technology that we provided in 2.3. And what we're going to do is talk about that in detail, what ZERT does and how it tracks this information, how it presents it to you, and talk about the roadmap, the complexity of the problems it solves for our auditors and our users. So what it does is it positions TCP/IP, the stack itself, as kind of the central control point or auditor for communications, and in terms of tracking what each connection is using or not using. And so TCP connections that are protected by TLS, SSL, or SSH, or IPsec, or they're unprotected, it will tell you about that. And we also provide support for Enterprise Extender, which takes in our SNA APPN connectivity for IPsec. So it will tell you if your SNA connectivity is secure, or if your TCP connectivity is or is not secure, and if so, what level is it using. And so basically this session is handled later today at 4:30, and we'll be in the Melbourne room, and that'll take probably about an hour to explain what ZERT is all about. But it's one of our main deliverables for 2.3. In this session, we're just going to introduce it, to tell you what it does, and how it does it will take quite a bit more time. Okay, now in ZOS 2.3, we have finally concluded what we believe is a long roadmap in our mail programs, and we have an update in 2.3. And so this one, unfortunately, is a relatively complex discussion, but it has some history behind it. And again, I'm not going to try to get into all the details, but I will try to at least paint the picture of what the roadmap looks like and things you need to think about. Now, this is going back all the way to 2014 that talks about our various statement of directions that we've made over the last 3-4 years. And 2.3, for the most part, closes the picture on this, where it will remove some of the mail programs that we had duplicate solutions that have dated issues with them. So basically what we've talked about is that SendMail and SMTPD our most updated SOD was in July of 2015 that basically said that those 2 programs would be going end of currency. And the strategic direction was our mail program CSS-MTP. And that's the one that we will be using for the future, and we have been talking about this for 3 years. And ZOS 2.3 will conclude that migration path. We've had migration health checks in the field in 2.1 and 2.2 for 2 or 3 years that warned our users that if you're still using these old mail programs, you need to think about moving off of them, or find yourself a migration plan for another solution. And we'll talk about what those problems are about. On this chart, we have a picture of the problem we have. So we have in yellow here, we have our 3 programs. CSS MTP, it's a client only. It's an SMTPD was a client and a server. And our third mail program was SendMail. So those yellow boxes represent 3 essentially duplicate functions. And the 2 lower ones here were becoming very aged and dated, and we could not simply keep duplicate solutions any longer. So we announced that strategy years ago, and essentially said that all of our future investment would be in CSSMT. And many of the decisions were made over a period of time through customer surveys that we asked for feedback in terms of what you need, what is it you do with mail on the platform, what's required. One of the things we found through those surveys, mostly through Share and Guide, is we found that almost every customer only uses mail as a client. So they basically send mail, they have jobs that generate some kind of an email, but very few customers use ZOS to receive email and do something with it. So that means the server, very few customers were using the server function only, but they did require a mail client function, and that's all we will have left. And so this is what the picture looked like in 2.2, 2.1, 2.2, and then when we move forward to today, what we'll say is the mail components that will change in 2.3, the X's show everything that's going away. So basically the main part of this picture is that both of these mail programs are now gone in 2.3, and all the interfaces into them that are X'd out are also gone. And then the one curious part is there's one arrow, one X in there that is still remains. That's interesting, and I'll explain that in a moment, how we allow a user to still get into SendMail, or it appears to provide SendMail access. And this is all part of the survey feedback, the migration information that customers gave us over the last several years that we created this strategy. So now moving on, what we'll see here is we'll talk about the bottom line is you can still use SendMail. What was SendMail was something that we created as a SendMail bridge to access CSS MTPD. So you can get to what we call the modern version of the mail program, which has been in ZOS since ZOS 2.13, or I'm sorry, 1.13. 1.11, I guess it was when it was introduced. So it's been here for several years in the product, but you can now access it through SendMail. So what our customers told us is that was still an issue for them, and we needed to protect that piece, and I'll explain it in just a moment. But for the most part, this is now the 2.3 picture, showing that everything is now removed, and that is what's left of our mail program. So now finally in 2.3, the removal of SMTPD and SendMail has finally occurred. And what was the reason for this? We explained this a few years ago, but just to wrap this up and conclude is it was just difficult, if not impossible, to continue supporting duplicate solutions. And so we had 3 mail programs that each user had kind of a lock into for different reasons, for different old programs. But nevertheless, we found the investment in all 3 of them was very difficult to keep up with. So if you start with some of the background, SMTPD was written in Pascal. It's about a 17-year-old program. It supports older RFC. It had no support for TLS or SSL or IPv6. And it had significant performance issues in the sense that that program was single-threaded. And there were cases we knew where multiple CPU processes would bottleneck on that aspect. So that was several design architecture issues for that program. ZOS Unix SendMail program was ported code back in 8.12.1 version of it, and that was in 2001. It's an out-of-date program, so we had to update it. Again, it would require a significant investment. So once again, we introduced CSS MTP in 1.11, and it has been our strategic mail program since we originally brought it in, and we have been talking about that again for about 3 years. So CSS MTP already provides superior performance, so the performance is much better, significant new function, broader function, currency compared to the older programs. CSS MTP test mode capability and something we call EZB mcopy have been put into place as a utility program, and they were provided, they've been available for some time. So this test mode has been available in 2.1 and 2.2 with APARs, or 2.2 base and 2.1 rolled back, to allow you to test your old software with the new program, and I'll talk about that in just a moment. Most of this information that's coming up on the next 3 or 4 charts I'm just going to touch on, but there is more details in the backup of this chart deck. So you'll see that here it's quite a bit of information of how we allow you to manage the migration to the new program. So finally, in 2.3, there's the conclusion, the removal of the old programs, SMTPD and SendMail are now gone. You can't configure it, you can't start it, they are gone. And so there's no replacement function provided as a server on ZOS. So there's no mail server left, as we found that no customer had that requirement. And so there's no point for the customers to just do not use ZOS for receiving email or forwarding or et cetera. They just didn't use the platform. They had other platforms they used for managing email. So while some users may be accustomed to issuing SendMail commands from the Unix shell, what we found was more problematic is that there was many programs and applications that might issue a SendMail programmatically through various commands, SendMail commands, to notify different users. So basically, for the use cases, the customers found, well, I got a lot of programs, I didn't aware of it, they would generate email, and they use the SendMail program, that's a problem for me. So that I don't even know how to track them down. So SendMail commands can still be issued in 2.3, that's been solved, and due to the presence of this bridge that we'll talk about, and I just touched on the previous chart. So let's talk about how that bridge works. So SendMail to the bridge. So this is to allow processing of existing SendMail commands from different programs to provide access to what looks like SendMail to bridge you into the new program. And so the SendMail bridge parses the input from the SendMail command and wrappers it, reads the mail message from the Unix system USS file, and the mail message updated by the SMTP commands that it needs and the headers. If no header specified, the input mail message itself. So what it does is it wrappers it properly based on that SendMail command, and the mail message is then transmitted to the JES spool file where it can be later read and processed by CSSMTP. So now it processes the message just as it would as any mail message that got to the spool file, and the processing is normal. It looks like SendMail is still present when in fact it was just bridged to CSSMTP. So now the SendMail command is now a symbolic link to the SendMail bridge. That's all it gets you to. The SendMail program itself is gone, but you still can get to the commands itself. You can still transmit mail using that same command. This chart 17 just shows an illustration of everything I just said. And I think it's a little clearer once you see the picture. So basically you can see the 3 steps. So with the SendMail command in this example, SendMail T with my message, the first step is what will happen is it will add the SMTP commands around it, around the message, and it will put it on the JES spool. And then later CSSMTP will read off of that spool and transmit the message just as it would as if it originated at CSSMTP. So SendMail appears to still be there, but we provided a way to bridge your programs into that one in 2.3. So that solved that migration issue for our users in terms of getting from SendMail into the new program. And so SendMail command is directed to the bridge, and this bridge actually is also provided to you as a command. So there's a command interface called EZAT mail that gets you to the bridge manually. So you can issue a SendMail command with the appropriate switches, the names, the message, and for example, here's an example of showing the wrapper we'll put around it, and the result will be a message updated with the appropriate SMTP commands, headers, etc., transmitted to spool file. And SendMail can be invoked from both OMVS shell and also through JCL via a BPX batch. So SendMail bridge is able to be invoked the same way as you did with these environments. Now the appendix has more information about what things didn't work, what we didn't bring forward, what are the little caveats, nuances, but for the most part you'll find it's very comprehensive in terms of preserving the SendMail support. Okay, the bridge, as I mentioned, is available in 2.1 and 2.2, and support for SendMail to the bridge was also provided with those releases with that APAR, and that APAR has been closed and available for some time. Now this command, EZAT mail, is the name of the SendMail to the bridge executable, so that allows you to get to it manually with the command line command. And so SendMail itself is unchanged, so we don't do anything with that, but symbolic link can be added for SendMail to invoke this actual bridge for testing. So in 2.1 and 2.2 we did not do anything with the actual SendMail program, but we can allow you to test by getting to the new program by testing this bridge with either this command or changing this symbolic link dynamically to test your programs to go the new path, go back to the old path, allows the user. So for 2.1 and 2.2 users, before you get to 2.3, when you must switch, it's recommended that you use this technique to test your mail programs. Okay, so now that was the migration into the new program and how you test your old program and what goes away. And then, of course, when we go to the new program, we realized as we worked with our users, there were migration issues. And the next 2 or 3 charts talk about mail migration complexities. And so one of the issues is enhancements were needed to improve compatibility. So there were some incompatibility issues with CSS MTP as users moved over. And the intent is to remove any inhibitors to allow our users to get from the old programs to now get to CSS MTP for all of their solutions. So the items that are here to improve TLS compatibility with mail servers, customizable @ characters, so we have that as a migration function, improved code page compatibility. So some of the non-US customers will have that issue. So this code page issue will hit some of our other geographies and most likely Europe as well. So again, just as in the previous, the SendMail bridge, the 3 items I'm talking about here, I have a couple charts on each, but the details is also in the backup because it's quite a bit of information. So hopefully that's the information that will help you get through the migration for SendMail. And again, the details are in the backup, and hopefully that's enough information for you for just as an overview. Now the next topic is what we added for wildcard support and job names on port and port range statements. And so looking at that now, in 2.3 we also offered port. So today we have port and port range configuration statements allows a user to restrict which programs can have access to a given port number. And so that's been available for a while. The port statement is used to restrict a single port. This job can only have access to this port and that only. And then you can also define a range of port numbers to provide access to multiple programs to allow that. The problem is the job name parameter and the port and port range were just basically very restrictive. But what they do is they authorize the jobs to bind or listen to that port number based on job name. Now, what we provided in the past was a wildcard character, an asterisk. A wildcard character of asterisk can be used to specify which jobs can bind, and it would allow the user some flexibility in terms of configuring multiple things over and over. And so what we did is you can allow the asterisk to be in any position or at the end of the actual name. And what customers have told us about that wildcard character was that it basically doesn't help enough. It just, still, they showed us many examples where they have to code configure or hundreds of port name statements because they needed more flexibility. So in 2.3, we finally answered that requirement, and we enhanced the wildcard support for job names and port range. And what we did there was we now support asterisks in any position, not just at the end of the character or the job name. And the asterisk can represent 0 or multiple unspecified characters. So now that when the asterisk is in the middle, it can be multiple characters. We also provide for the wildcard support the notion of a question mark. The question mark represents a single unspecified wild character, if you will. So basically a little bit different, asterisk and a character, and that provides significant flexibility. So it is possible for multiple port range statements to match the job name. So you get, now there are cases where you can get, I got several job names that match this qualification, and we have a very simple algorithm to tell you how the matches are resolved. So job name is compared character by character, left to right, until we find the most specific match. It's very, very common algorithm that's used. So when a character in a job name does not match the specification, the following hierarchy is used. So a non-wildcard character would certainly take, if it's non-wildcard, it'll take precedence when we have a conflict. A single wildcard character, a question mark, will take precedence over an asterisk. So basically that's the tiebreakers in that order. So a couple examples helps make this clear. So example 1, I have 2 port statements, 6001 and 6002, with the following 2 job names, US question mark and US asterisk or asterisk. So then if a job name with user 15 binds to 6001, because the job name of user splat R would match single wildcard of question mark beats multiple. So in this example, if you see U matches, S matches, and then when we get to the question mark, it would basically, for user 15, would be a closer match to 6001 because question mark takes precedent over this one because that's 6002 and that's more general. That could be multiple characters. So question mark, so the first, going left to right, the first that's more specific, we'll select that port number. In this example, we'll select 6001. Example 2, again, I have 2 port names and I have the wildcard character shown here. Now if a job name with user 15 binds to port 6002, and the reason it does is the job name of US asterisk R asterisk would match. So in that case, you would see that S is more specific than this, so we would go to 6002. Okay, so basically it's very simple, just going left to right till you find the first one that's not specific, and you keep going till you can eliminate the job. So now you have plenty of flexibility, and so customers that would have hundreds of port statements can reduce them to just a handful. 2.3 also, for each release, we have this issue of shipping something for our ATTLS support. So every release, as we know, SSL is constantly being updated. And so I think most of you are familiar with this picture, but this is basically trying to give you an overview of our ATTLS support, application transparent TLS. And what you realize or recall is that we wrapper in green here with our policy support. We wrapper and call SSL on behalf of applications. So the green boxes represent how we control the invocations into SSL. And so, again, it's stack-based support. I think most of you are familiar with transparent to the application, and we use policy-based configuration to control what applications are using this. And it can be fully transparent, it can be partially transparent. An optional API allows the application to inspect or control some aspects of it. We also surface that to our users, but basically it serves as a remote endpoint. It sees an RFC compliant implementation. It interoperates with other implementations, so the other platform doesn't have to know anything about how we're using SSL. It basically meets the standards. But the notion that we provided the support is very good for our middleware that sits on the platform. It's not so good for COM server because you can see the issue with this is that you're going to have a constant tax on updating the green boxes all the time. So since ZOS handles the TLS processing, exploiting applications, it's necessary for us to do this. And this usually includes externalizing new options and parameters through the policy part. So every time SSL is updated, we have to surface that to our users, updating the configuration assistant to support those new parameters. It may include updates for things like netstat or PA search commands, updates to IPCS, updates to the NMIs, or any of our record keeping for our invocations. So that happens in every release. And so in 2.3 we have a long list, just as every release, of standards and RFCs that we will need to update for our ATTLS support. Here's a list. I won't not go into every one of them, but you can go read them on your own. But basically you'll see, for example, the first one is provide FIPS 140.2 security levels to enforce cryptographic key strength. So it goes from an 80-bit to a 112-bit, and I think there's 3 levels now supported. That's provided in 2.3. We have support for new certificate processing. We have support for the certificate protocol that allows us to validate. There's this notion of stapling certificates to provide optimized certificate validation. That's also added. So support for new 128-bit minimum and 192 min profiles for Suite B profile, again for another set of RFCs. So you can see all the associated RFCs that were added to this release. And we have this thing called at the bottom, the signaling cipher suite value, which allows, this is a protocol to prevent a man in the middle or a client from invalidly lowering the security level that you're trying to select during the handshake. So that's a problem that's known in the industry. That protocol solves it. So in our ATTLS, this is a list of the functions that we had to add in 2.3 to update our ATTLS. Now I have a few other miscellaneous items in 2.3 we'll talk about. So for Z14, we have hardware enhancements that affect communications. So on Z14 platform, we have a new OSA Express 6S, And essentially, it looks externally somewhat like the previous OSA 5, but it's a technology refresh. So inside the OSA, it's a complete new set of architecture and hardware. It's supported on all existing releases. There are APARs we have for some minor changes that we did in software to support the new card, but for the most part, it looks like a technology refresh. The value of technology refresh to the platform is optimization, RAS improvements, et cetera, and it provides access to new functions that we could do in the future, for example. On Z14, we introduced also a new Rocky card, which is branded as Rocky Express 2. It's also 10 gigabit. So both of our cards offer 1 and 10 gig. Rocky is 10 gig only. Over on the right, I show all the OSA features, and all the OSA features that we have with OSA Express 5 are continued with OSA Express 6S. And for Rocky, it was also a technology refresh, so it's a new card inside of the Rocky. It's updated. The main function that was provided for Rocky Express 2 is the virtualization was increased, so now more users can share that card. It used to be 31 users or virtual functions per card, and now in 2.3 it's 63 users per port. So that would be 126 per card, so that more than doubled or tripled the support for a single card. So the only reason I'm reluctant to say that on the previous machine, Z13, we could support up to 18 cards. Now 16 cards, and on the new platform we only support 8 physical cards for Rocky, but the number of users of each card went up by almost a factor of 4. So in terms of the usage and its bandwidth, it's essentially the same, if not more. We had some APARs we had to ship for compatibility. ZOS 2.3, we actually had quite a bit of work to do to support the new card. So Rocky Express 2 and OSA Express 6X, new adapter cards, very important for ZOS Com Server in terms of performance and, again, RAS for Z14. So new adapter cards. This is a function called Hypersockets Converged Interface. I talked about this just in the previous session. Most of you are not going to see that. And in each of my presentations, I will mention it again. It's a 2.3 item, but it's a very interesting usability item. I'm just going to introduce it here and not really talk about how it actually does it. But if you are a user that's interested in hypersockets, or you use it today, or you're considering using it, I would encourage you to take a look at this item. It's not been shipped yet. It will ship in the first quarter of 18, but it has been announced. And what this item is about is it allows us to provide significant usability enhancements in terms of how our ZOS users exploit hypersockets. In this picture, all I'm going to do is just cover what it is, not how we do it. But basically, with taking the most simplest diagram of 2 CPCs, they may or may not be in the same sysplex. In this example, they are. But what it looks like here is that with just 6 LPARs and 2 machines, the most simplest diagram, I have a user that this administrator has to maintain 3 networks. He has a LAN that he accesses through 2 Ethernet adapters, which we call OSA, and he has 2 internal LANs, which are called hypersockets. And this user is maintaining 3 networks, 3 IP subnets. And this is, in this example, network X, network Y, and network A, if you will. And so this is 3 broadcast domains, physical networks. The user could divide those up into multiple networks with subnetting, but just to keep the discussion simple, 3 networks, 2 inside the machine, 1 outside the machine. And so now every LPAR has to maintain 2 interfaces. So the LPARs on this machine access network X and network A. The LPARs on this machine access network Y and network A. And they have IP routes, IP interfaces, IP addresses, etc. And this is what hypersockets looks like today. And so what we did in this release is we will introduce something called Hypersockets Converged Interface. We essentially bond the hypersockets with the OSA, and hypersockets for all practical purposes disappears from the user. The user doesn't define it, manage it, start, stop it, although it could. But for the most part, every LPAR now sees 1 single interface. And what's really important is how this really becomes 1 network now. So I talked about X, Y, and A. Now it's A, and A. And the administrator says, I'm taking the day off because this is much easier to manage. I got one network instead of 3. Every host only has one IP address, so I'll give those IP addresses back to the guy that manages them. And he's a happy guy because it's much easier to manage. So how do we use hypersockets? It's done through this converging. It's basically like logical bonding of NICs, but they're different mediums. But essentially, that's what that item does, is puts them together, starts and stops, and just associates hypersockets with a OSA. And we do that with the network identifier on the port. So we deliver that in 2.3 first quarter. Why? What is the value of it? It would take more time to explain. The charts are available where you get the charts from my previous session. If you have questions about this or you see something that's interesting, you want to talk about it while we're here, we can do this. So hypersockets converged interface solves 2 significant problems on the platform and provides significant usability improvements around hypersockets. And so that takes about 45 minutes to explain, and that one's also in a different session. So that one was covered this morning. Again, the charts are here, and I'm still here for a couple days if you want to talk about it. Also, part of our innovation on System Z in terms of communication, hopefully most of you have heard about shared memory communications. That's something we provide on Z. I'll be talking about that this afternoon as well. Here's a picture of kind of the architecture of it. And SMC is this notion of sharing memory with each of your peers, and they just communicate directly in the memory. They don't use TCP/IP. It does not use packets. It uses new technology to do this. We've had this available for 2 or 3 years, depending on which aspect you're looking. SMC Direct is the internal version of it, and SMC Remote is the remote version of it. It exploits RoCE to use this form of communication. They're both now available. So in this example, what you would see is these 2 machines would use RoCE to communicate using SMC. And then if these 2 LPARs were to communicate, they could discover each other dynamically, and they would use SMC Direct, which means they use the same semantics, but they don't send the bytes over the wire. This is ISM, Internal Shared Memory, is a new device that we created on System Z that looks a lot like hypersockets, but it's significantly different in the sense that there's no TCP, there are no packets. There's no TCP/IP processing, so we connect with TCP/IP using SMC, and then we dynamically get out of the way and let the applications on the socket level talk to each other directly after we connect. And it's a very interesting technology, and we're going to be providing it for other platforms. And so if you're interested in it, I can talk to you again while I'm here, the 2 variations of it, and I do have a presentation coming up later today on this technology. And what's the point of it or value of it is basically about optimized communications, exploiting RDMA semantics. And the optimization is quite compelling in terms of CPU reduction, throughput, latency, et cetera. It's an interesting step forward in terms of it's not a small difference. It can be, in some cases, a very large difference. So shared memory communication is too much to talk about in 2.3. What did we do in 2.3? We added support for RoCE Express 2. So again, when you go over the wire, we can use RoCE Express or RoCE Express 2. We had to do that in 2.3 for SMC. So that one I'll talk about some background on SMC, SMC Direct, other platforms that are coming, and RoCE Express 2 a little bit in the next presentation. So that one is now at 2 o'clock and actually installed back in that room. So that's SMC overview. If you've not seen it, I'd encourage you to take a look at that one. Okay, also in 2.3, we have support for enhanced system symbols. So in 2.2, we added enhanced system symbol support. We added the ability to support longer system characters up to 16 and longer system symbol substitution values in 2.2. And note that the length of the substitution values should not exceed the length of the symbol name itself. So now somewhere in the process of adding that, underscore support was added to become a valid character. In ZOS, when we delivered in 2.2, we missed that capability for underscore. So we had to add that. So 2.2 COM server did not support it with the extended system, and 2.2 COM server did not support longer substitution values in some cases. So we fell short on a couple of the items in our longer system symbol support that our users said, I still need that capability. So in 2.3, we've closed that gap. So ZOS 2.3 adds support for system symbols with an underscore character and for longer symbol substitution. So that was added in 2.3. IPv6, I don't know if we have IPv6 users. Some users are interested in this, some not. I'll leave it up here. Does anyone have interest in IPv6? You may or may not. Again, it's in the chart deck. We find that it's kind of a niche depending on what geography you're in or what industry you're in. But IPv6 get adder info standards compliance, we were a little bit off on that. So again, the background on that is the API did support v4 and v6 address lookups. So if you did get adder info, it was very flexible, very powerful. But there were some anomalies in terms of switching back and forth to v6 and v4, what you actually got back. And the ability to request, it also provided that ability to request just v4, hey, just give me v6 information or both. And supported on ZOS since like 1.4 when IPv6 support was introduced, so that API has been there all this time. It was initially designed using the latest level draft of the RFC 2553. And you can see that's a pretty old number. After ZOS introduced this new API in 1.4, a later RFC course replaced it, and that one, 3493, was to make this one obsolete. So this item is catching up with that. And so our implementation was very close to being compliant, even with the new one, so there's not a significant change, but there are some minor changes. And as a result, an IPv6 get adder info call could have some changes. I don't necessarily need to spend the time on them here, but there's one specific scenario that's called out. If you have this particular case, prior to 2.3, this would have resulted into only IPv6 addresses being returned on that call. And now after 2.3, if you have this same set of flags or use case, it will return both v6 and v4. So the little bit different API result, we have to warn our users about that change. So it's important to know that application can see a little bit difference if you are enabled for v6. So we don't expect many applications to be affected by this, but if you do have v6 enabled, you need to be aware of it. Okay, SWASS, Sysplex-wide Security Association. So most of you are familiar with the item. Here's what happened in 2.3. Sysplex, so what is it? SWASS combines Sysplex functionality with IPsec technology. And it's been a function that we've had for quite some time. Sysplex distributor negotiates SA security associations with remote clients using IKE. And copies those security associations or shadows them are sent to the target stack. So this negotiation occurs, and then we send the information to this target stack so they now have available, and it's also can be stored in the coupling facility. So target stacks can use the associations for encryption and decryption of data. Backup can recover the SAs in case of a planned or unplanned DVIPA takeover. Information about the SAs is maintained in EZB DVIPA in the coupling facility, which is called, in this case, a list structure. So this is existing functionality. So the problem is that this list can be used for takeover in a Sysplex distributor environment. And in 2.2 and earlier, the number of available lists has been fixed at 2K. The number of lists actually utilized is determined by the number of DVIPAs and the number of security associations or tunnels that are created. So that number has been quite sufficient for some time, 2,000 associations. In 2.2, the maximum number of DVIPAs for a single stack was increased from 1K to 4K. So in release 2.2, we spent quite a bit of time fixing scalability issues. Many things scaled up. And primarily we added 64-bit support. And we also, the IKE daemon was redesigned to make heavy use of multi-threading and also to increase its ability to scale. Now these scalability improvements along with growing adoption of IPsec increases the likelihood that customers would encounter a problem with this 2K limit in the list in EZB DVIPA. So that 2K was a problem. That was a cap that was affecting some customers. So SWASS was updated in 2.3. It adds a new VTM start option to control this change. I mean, because each system in the Sysplex has to have the same value. So that specifies the number of lists that we need to support in this Sysplex. So the DVIPA list count can be set to one of 4 possible values. The default is 2K, but it can also be set to 4, 8, or 16K. The same value should be specified in all ZOS systems in the Sysplex. All systems to use this function must be 2.3 or above. So we don't believe there's too many customers that have this this scalability issue, but we believe they will have it in the future. So there it is. This is what you need to think about in terms of how to get to this, to get your systems there. And this is changeable by modified VTM ops. You can use the CF Sizer tool. It's been updated to provide some guidance about, hey, this is how high this list is getting. You need to think about changing this in your sysplex. That's been provided. Also in 2.3, here is a list of our 2.1 device driver support. This is the things that's been announced for some time now. Most of you are familiar with it. And some of the down at the bottom of the list you probably, unless you're my age, may not recognize. But some of them have now been deprecated. And up here you'll see more of our modern device drivers or device interfaces. And what we've announced is that some of them will be going away. So in 2.2 we removed the ones shown here. So this is old news, hopefully for most of you if you're 2.1 or 2.2. And then in ZOS 2.3 we had talked about removing the remainders, and so now they are removed. So everything from SNA-Link down are now gone. And that's hardware that's essentially obsolete, that's been obsolete for many years. And so most of this is very old news, but because we dropped those in 2.3, we're going to make sure that it's brought to your attention during the release overview. So that's device drivers that's removed in 2.3. Again, old hardware that we believe affects no one, but we did deprecate them and finally remove them in 2.3. Okay, and also another program that was removed, the statement of direction, the trivial file transfer program, that statement of direction dates back to July of 2015. The ZOS 2.2 was planned to be the last release to include this program. And in 2.3, that program, the trivial file transfer program, has now been removed in 2.3. So that's the final step in that one. Configuration Assistant. Now, most of you are familiar with that program. That's a utility we provide to modernize how you configure TCP/IP. And so Config Assistant is a kind of a roadmap function in terms of we started with basic support, and each release we ship something new. So basically what's happening, if anyone's noticed, is the skilled in our field is changing slightly over time, and skilled ZOS system programmers and administrators are aging. You know, what's a PARM live? What's a data set? Leading to concerns about, okay, what happens in the future with our new guys that come in and try to configure and make changes. So Configuration Assistant was created, and initially it only supported comm server policy-based networking functions, things like IPsec, ATTLS, and IDS, intrusion detection. Very important, but security functions that were in policy agents. So step one, Config Assistant provided support for policy-based definitions. TCP/IP configuration is not that complex. Some aspects are not intuitive, though. They do interact, and it's not quite obvious. So some users must look through a lot of documentation. Some statements are not easy. So basically, we realized, okay, that was a nice first step. But TCP/IP itself, the stack definitions, were also very hard. So the question was, when will Config Assist provide that support? And 2.2 provided a new TCP/IP configuration perspective in Configuration Assist. Support's provided for both the novice and more experienced users. So we have the same GUI, same ZOS MF APIs. The configuration model supports levels of configuration, which includes sysplex, image level, and a stack level. So you can have different levels for your operating system, with the goal to allow for configurations to be applied to a group of stacks. So I want this group to have the same configuration. CA assists with install of these generated configuration files as it does with policy configuration. So once you define it in Configuration Assistant for a stack, you can install that configuration. Now, most customers, they said, well, that's interesting, I like what you're doing, but guess what? Most customers already have a configuration. So that TCP/IP profiles are needed in a way to import. I really need to get my old configuration into the tool. I need to start that way. So we provided this ability to import. TCP/IP profile import, the Configuration Assistant was shipped in September of 16. That was the APAR that provided it. It requires companion ZOS comm server APAR, which is also included here. TCP/IP profile import works in 3 major steps. It will basically, you can run this command, very TCP/IP export profile operator command, in ComServer to format a TCP/IP configuration into a file that can be read by configuration system. So first step is to export it. Second step is import that file that you just created into configuration system. That's step 2. And now you can correct any errors as required to make the imported configuration installable. There might be some things that were left over or incompatible that you had in your old profile, and that you have step 3 is correct whatever you just imported. And so that was provided, so that gave you the ability to go get your old configuration and bring it in. And then finally, we have this thing called change set support. And so now what we did is we gave you the ability to configure a profile, export it, bring it in, change it. But what you didn't have the ability to is to make dynamic changes. So as you could do very-obey processing with a standard configuration, Configuration Assistant, the previous step didn't have very-obey light processing, dynamic changes to Configuration Assistant. So very-obey is supported by Configuration Assistant now by introducing this concept called change set. You create a change set based on existing configuration object, a stack or a group of stacks or a usable configuration or a sysplex. The change set is seeded with the configuration from the object it's based on, and you edit that change, whatever you want to go into it, edit the change set to make the configuration changes you want. And when you install that change, configuration system will generate the very-obey command for you. So now you have the ability to dynamically update your configuration that you created with Config Assistant. So very-obey files, once placed under the system, are manually applied by the operator. Provides operator for opportunity for review. So, okay, this is what you brought in. I want to review it. Now I can activate it. It's business as usual. But it came from Configuration Assistant following that process. Change set support is delivered in 2.2 via APAR, and it will be delivered in 2.3 base. So Configuration Assistant, what's new in 2.3 is change set support, dynamic updates to your configuration. And then finally, we had something, this may or may not ring a bell, we had something called VTM. And VTM has a trace called VTM Internal Trace, and we made some minor changes to it also in 2.3. And what we've done there is we have this notion that we run the VTM trace by default, and it had a long set of base options, and there are many, many more options, but that was the base options that the user could not necessarily control or turn off. Now we had customers express concerns about running those options. Well, why can't I control them, and why can't I turn them off? And we can tell the user why you would not want to do that. But given the infrequent need for the storage option and the CPU costs associated with tracking storage, we did ship an APAR to allow that to fall out of the user-controlled option. So now when you bring up VTM, SMS is off finally because it was one of the big CPU cost consumers of the tracing. And so we believe that disabling SMS with that change fits the needs for most of our users. It's, okay, that's interesting to know about. Thank you for shipping that. Now, that APAR was shipped, or that change was shipped by that APAR that you see listed here. That's available in 2.1 and 2.2, and it's the base behavior for z/OS 2.3. So SMS was dropped out of the base. It provides us some CPU relief. And the question is, well, then what's the downside of turning it off? Well, you might need it. And the question is, how do I predict that? You don't know that. But this next chart gets into some interesting discussion. So there's an APAR, there's a new function that allows the full capability of controlling or disabling all the options. So basically what happens is that user said, well, I like turning SMS off, but I'm a guy that I don't have a lot of SNA activity, and I have generated a field problem in 2 years, so I want to turn it off. I'll take the risk. And so we shipped this function to allow them now disable everything, and that was shipped via that APAR. And this support does not change the minimum recommended, so we don't change the defaults. We still recommend that you run with that list of defaults, but we'll let you turn them off at your own risk, and that's basically what that item does. So there's a notion that's basically says here's a safety, you can remove the safety on this device, and now you have nothing running, and you get that CPU cost back. So disabling any of all these options will impact the ability for support to basically diagnose a problem. So you might be in a recreate scenario. And again, if you're a customer who says, well, I haven't created a PMR in a long time, so I'm going to take the risk. So there you go. It's possible that could be needed. So This new VIT option control capabilities is enabled with this new VTM start option called VIT control. So now the user has full control. Prior to it, it could not control those base options, but full control says, I can do what I want now. And so the basic way that works is if you leave it at base, which is the way it's shipped, it says it's the way it was, but you can say, no, I want full control. Full control says you can turn on and off every option by itself. And we have a health check that's out there that says, whoops, somebody turned off everything or turned off something in the base. And we'll just warn you, hey, do you know you're not running with the base, the IBM recommendation defaults? And it says, yeah, I know that. I turned that off because you gave me the ability to do it. So I know what I'm doing. So basically a health check that just tells you did it. And there's the capability now with the start option that says I want to put VIT control in full mode. And now everything I turn on and off is displayed just as I controlled them. So that's shipped in 2.3 as well. So full control. And finally, here's a list of the other options or the other presentations while I'm here. So shared memory communications. XERT is the most important one. I encourage you to see that one. And I also have the OSA presentation. So I will be giving that one as well. There's the session names, EC, EE, EJ. And then we'll repeat the technical update tomorrow because it had conflicts with several other sessions. So that is the other sessions I have while here. Also, I have one final plug for IBM Dock Buddy. And hopefully some of you have heard of it. But this is a mobile device application that you can download right now. And what does it do for you? It allows you to look up IBM error codes and messages with return codes. All the codes that you had to dig and find through a whole set of publications, it can now be in a handheld application. So that's available now. And it's very handy, and our publication folks would very much like me to give it a plug while it's here. But I would encourage you to just download it and play with it. Plug in a few error codes and see what it does. But it's very interesting, and it's had hundreds of downloads, and it's only been available for a very short time. So we'll see how the reviews go. But you can get it for both iOS and Android devices. It's on the App Store now. So Dock Buddy helps you with looking up error codes, not just comm servers, across the whole entire ZOS product line. And so thanks again for coming today, and don't forget to fill out your feedback. This is session EB today, and so with that, I think that was the last slide I have, so thanks again for everyone. I don't know if there were any questions for anything. I realized that pace was relatively quick, but if there was any topic you saw that you would like me to cover, or if you see one of those sessions that you'd like to talk about and you know you can't make it, you can just contact me because I'll check my email while I'm here. I'd be glad to find some time to talk to you about the other topics as well. So thanks again, and I think we're good then. All right, thank you.
Thanks very much.